We all love the sunshine. There's nothing like the feel-good factor of a hot sunny day. And there's nothing like the healthy glow of a newly acquired tan to make us feel fitter and more attractive. But in reality, we could be doing ourselves a great deal of harm. Every year, thousands of us jet off around the world for our holidays in the sun. And every year, thousands of people are diagnosed with skin cancer. With the protective ozone layer diminishing and more harmful rays than ever pouring through, the incidence of serious skin damage is on the up. There's no doubt that skin cancer is linked to overexposure to the sun, but it is by no means the only factor. Despite staying out of the sun, Sarah Walsh developed skin cancer in her early 30s.
I was diagnosed in about October 2000, and it was a mole on my leg, and I'd had it for a long time. Finally went along to my own GP, and she referred me to a consultant at Adam Brooks. He said to me that it was something called superficial spreading malignant melanoma, and although that is quite serious, I was confident in myself that it had been removed and that it wasn't likely to come back in my case, because I was young and fit, and I've always had quite a healthy lifestyle, so I couldn't see why I would have any further problems.
Unfortunately for Sarah, the fact that her melanoma had spread means her outlook is poor. Melanoma is a type of skin cancer that can spread to any part of the body, and doctors can never predict where it will appear next. Sarah's disease is likely to be fatal, but neither she nor her medical team know how soon or which organs it will affect.
Patients want to know what's going to happen to them, and whilst you can give them statistics, it's such a variable disease you really can't say for sure.
Everybody's different. Every single patient's experience, their life story, their family configuration, what they know about cancer is quite different, but it's usually terrifying. I don't think there's anybody who could fear more the word cancer.
Despite modern medicine's best efforts, once melanoma has spread, there is no really effective treatment for the disease, other than surgery, which is frequently not possible.
Unfortunately, melanoma cells aren't particularly sensitive to radiation or radiotherapy, and so far all the chemotherapy treatments that have been tried have very little effect.
Cancer touches most of our lives. Many of us will know someone with cancer. We may even have lost a loved one to the disease, and 1 in 3 of us will develop it. But what is cancer?
Cancer is a disease that is characterized by cells in the body that sort of do 3 things. They sort of grow when they shouldn't, where they shouldn't, and how they shouldn't. So they misbehave. They don't act like the cells around them. They now become aberrant and exhibit behaviors that really cause problems in terms of patients' health.
So if cancer is our own cells misbehaving in some way, what causes this to happen?
Well, what we've learned over the last 20, 25, 30 years is that all cancers, as their base, have problems with their DNA. What all cancers have in common is they have misspellings, if you will. So they have words that no longer do what they should do. So they direct the cells to behave in ways that they normally shouldn't. So it's these sort of DNA mutations that cause all cancers.
DNA is the chemical code that holds the instructions for life. It is made up of 4 bases represented by the letters A, C, G and T. Mutations arise when the letters in the DNA code get altered, causing altered proteins to be produced. Natural mutations occur when the body's own enzymes make a mistake in the DNA code. But mutations can also be caused by damage to the DNA, either by chemicals or by radiation such as ultraviolet light. And it is UV that is the biggest single risk factor for melanoma.
It's the times when you go out on the weekends, go to the beach, outside, at the picnics, wherever, and get terribly sunburnt. That's the worst time. That's the time you're doing the most damage to your skin. Because we have such a hotter sun, a hotter summer, and much higher incidence of melanoma and skin cancer in Australia, we've needed to have this prevention campaigns for many years. And they're finding that it's so preventable. So if we could increase people's awareness to skin cancer, awareness of sun protection, awareness of the damage the sun can do, and the ways you can prevent skin damage, we'll find our rates of skin cancer and melanoma will reduce in time.
And what other lessons can we learn from the Australian experience?
The earlier you detect it, the better it is for the person who has the disease. So the first time people notice changes within moles, new spots that weren't there before, they know they need to do something about it.
Signs to look out for include moles that have changed size, shape or colour, moles that have developed irregular edges, and moles that weren't there before. In fact, any new spot or unusual mark that doesn't go away needs checking by your GP, as does any kind of sore that won't heal.
The public ideas about sun awareness, their attitudes need to change. Being brown, via the sun is not necessarily being beautiful, and you can go on holidays and come back without a tan and still have a good time.
Probably one of the best known features of cancer is its ability to spread throughout the body. Cells from the original tumour can travel to any other site, where they settle and divide uncontrollably, forming another tumour. This is called metastasis.
About 2.5 years later, I had a lump in my leg, which turned out to be a metastasis, which was removed, and I went away fit and well again. And then later on, I think it was about 1.5 years later, I had a lump on my shoulder, which turned out to be another metastasis.
So one can compare it to a nicely ordered garden where you have nice rows of plants all arranged as you like them, and now you have weeds that come in and start growing where they shouldn't, sort of messing up the normal order of that garden. So this is a real clinical problem. This is what causes most problems when people go to hospital with cancer.
I've been through angry and depressed and why me, and frustrated because the things that I do don't seem to work, and I've always kept reasonably fit, and it's just something that you can't really control. There doesn't seem to be anything that you can do to control it, and that's quite true of the medical side of it as well. It's still very much in the research phase, where there's things that they can try, but there is no cure.
I've been involved in treating patients with melanoma for probably 20 years now, and I think it's fair to say the treatment hasn't really changed a great deal. There's been huge efforts by the research community to improve treatment, particularly with chemotherapy, but as yet not really come to very much. So it just shows you what a tough customer we're dealing with.
But that picture may be changing. This is the Wellcome Trust Sanger Institute in Cambridge, home of the Human Genome Project. Scientists here are exploiting the knowledge produced by sequencing the entire genetic code for human life. They are using this huge amount of information to gain unique insight into the underlying mechanisms of cancer.
So the Cancer Genome Project was born out of the Human Genome Project, which was a massive worldwide effort to understand the book of life, to understand how it was spelled, what the words were, and how it was all put together. We know that cancer is all generated by alterations in that code, that sequence, that spelling. So we came along to try to take advantage of the fact that we now had what the book looked like.
The Human Genome Project is a list of all the genes that go to make up a human being. The Cancer Genome Project aims to zero in on genes that have mutated, resulting in cancer.
So the genome is a very large thing. It includes I think the current guess is about 25,000 genes. So you could look at them one by one, starting at number 1 and going to number 25,000. Or you can do what we do, is try to take what we've learned from the 20, 25, 30 years of cancer work that's gone on and say, we know that these processes, these things go wrong in cancer cells. We have some idea about some of the genes that may be involved. Those become the most likely places to look to start with. So we try to line up the usual suspects.
Although they were looking for needles in haystacks, the team's wealth of experience meant that they very quickly came up with some exciting leads.
One mutation that we found to date is in a gene called BRAF. What we do in the lab is to actually take DNA. We make DNA from these tumors and ask the question, if we read the sequence, we sequence it, actually base by base, A by G by T by C. Is there any evidence that any of those spellings is altered?
Finding BRAF was a massive undertaking, involving the sequencing of millions of bases of DNA. Having found the mutation, they first had to repeat that work to prove it was a real result. They then had to repeat the whole process with many other melanoma samples to show BRAF mutation was a significant factor in melanoma. It soon became apparent that they were onto something big.
About 70–80% of melanomas have exactly the same mutation, the same misspelling in this gene called BRAF. And from here, one begins to get a sense that this might be a very important alteration that occurs in this particular tumor type. And we've extended that to actual questions, what is BRAF doing in melanomas now?
It turns out that BRAF is an important protein for cell division. In its normal state, it is inactive, but mutated BRAF is permanently switched on and kickstarts a chain reaction that causes the cell to divide.
So for BRAF, what we immediately started was a program to try to understand the shape of the protein and how we could design drugs, small molecules, small chemicals to fit into the protein to make it think it was turned back off.
Further experiments confirmed that turning BRAF back off could stop melanoma in its tracks. A number of drugs have now gone forward to clinical trial, but drug development is a slow process and may not lead to a new treatment. And for Sarah, the progression of her disease means she may not live to benefit from a new BRAF therapy. Sarah is back at Addenbrooke's Hospital for a CT scan. The scan allows doctors to use X-rays to look inside Sarah's body and see just how far the disease has spread. The news is not good.
And I had a CT much more recently, which showed that I had other metastases which couldn't be surgically removed. So currently we're just seeing how fast things are progressing, and there's a couple of trials that I might go on to. We're just waiting to see at the moment what's happening.
No two people are the same, no two sites of melanoma are the same, which makes it even harder. The skin is so different in its attributes all over the body. So melanoma can be, I like to sort of compare it to the three-lane highway, and that for some patients, you know, the disease is dealt with and it will never recur. They're sat on the hard shoulder. For some patients, the disease will continue to rumble, just travel slowly, causing small problems from time to time, which we would, intervene surgically. They would have it removed, and then may, not cause any more problems, perhaps for a lifetime. For some patients, the disease may move very rapidly, and the disease may metastasize at a very unpredictable rate to unpredictable organs. Melanoma can settle pretty well anywhere in the body, and the disease can progress very rapidly. Then the problems start because we do not have any cures or treatments that are effective for melanoma. So chemotherapy or radiotherapy may be given to try and control symptoms. We call it palliation of the disease. So we may try and control the symptoms depending on the site of the melanoma, but then it's really coming to terms with the prospect of dying.
It was a shock to find that it had spread to my internal organs, and because I wasn't really expecting that. I always kind of thought it would work out all right. And it may still. I've still got a couple of avenues that I can go down, a couple of trials that I can follow. So I'm not at the end of the road yet.
Cancer therapy is rapidly evolving. I mean, it's literally changing as we speak. And it's all because we're beginning to understand those underlying events that occur at the DNA level. How quickly that change will translate into what patients can be expected to be given when they go to hospital, I think, is an open question. For some cancers, I think it'll move much faster than others, but certainly in 10 or 15 or 20 years' time, what will be done about a patient who comes in with cancer, how that cancer will be treated, will be fundamentally changed by the types of efforts that are going on around the world.